Assalamualaikum and a very good evening. My name is Intan Nur Haslinda and I will be presenting my lab report on Bernoulli's theorem. So let's start with the introduction. Bernoulli's principle states that in a steady flow of a fluid, the pressure of the fluid decreases when the velocity of the fluid increases. Bernoulli's principle is very important as it is used in the design of airplanes, boat hulls, fan blades, and cars. Meanwhile, Bernoulli's theorem pertaining to a flow streamline is based on three assumptions, which are steady flow, incompressible fluid, and no losses from the fluid friction. The validity of Bernoulli's equation will be examined in this experiment. The objective of this experiment is to determine Bernoulli's theorem, which can be applied to a venturimeter, consists of converging portion and diverging cone. The diagram shows a venturi tube. In this experiment, the Bernoulli's equation will be verified with the use of a venturi system connected with manometers to measure the pressure head, total head, and velocities of fluid at known points along the flow. Also, the velocity of the fluid flow will be calculated using Bernoulli's equation, which is P over rho g plus V squared over 2g plus z. According to the Bernoulli's theorem of fluid flow through a pipe, the total head at any cross-section is constant. Since the centerline of all the cross-section lies on the same horizontal plane, the difference in height can be disregarded. Therefore, we can cancel out z in the equation. In a real flow, due to friction and other imperfections, as well as measurement uncertainties, the results will deviate from the theoretical ones. The following shows the setup of the experiment, which consists of Bernoulli's theorem demonstration unit. This unit consists of manometer, test section, water inlet, unions, air bleed screw, discharge valve, gland nut, hypodermic probe, and adjustable feet. The experiment was conducted using the following procedure. In this experiment, there are four main things to be calculated in order to determine the difference in value between VIB and VIC. So the first one is VIB by using the Bernoulli's equation, and we can further derive the equation into V equals to square root of 2g h asterisk minus hi. And the second thing to be calculated is the area of each of the cross-section, and we can calculate using A equals to pi d squared over 4, given that the diameter of each cross-section is the following. The third thing to be calculated is the volumetric flow rate of each trial, and we can calculate it using Q equals to volume of water over time taken. And the last thing to be calculated is VIC by using continuity equation, which is V equals to Q over A. This is the results of the experiment. The reading of H asterisk Hi and the time taken of water to be filled until 3 liters are recorded. The experiment is conducted in 3 trials with varying flow rates to manipulate the result of the velocities. From this result, we observed that when the diameter of the cross-section is smaller, they were increasing in velocities along the distribution tube. The results shown that larger pressure difference gave out the most speed of fluid flow. Also, as fluid flow through the venturimeter, the head is higher at the narrower tube and vice versa. The narrower tube leads to high velocities and low pressure. Also, the highest volumetric flow rates gave the highest velocity. It is observed that all of the calculated velocity obtained from Bernoulli equation had the highest values compared to velocity obtained from continuity equation. The difference between VIB and VIC was calculated to show that the value of VIB are greater than VIC. As calculated, there was one negative value which should not happen. This may be because of parallax error during taking the reading and air bubble trap inside the tube. In conclusion, the Bernoulli's theorem is accepted, as Bernoulli stated high velocity of fluid flow result in low pressure, and based on continuity equation, smaller area result in high velocity. Thus, the result proved both equations could be used to determine the velocity of fluid flow in manometer. Even the value is not exactly the same, but the pattern of increasing and decreasing at the converging and diverging portion is the same, so that as the velocity increases, the total head pressure also increases for both convergent and divergent flow. So that's all from me. Thank you.